Software testing is very different from quality control performed in assembly line production type of systems and should be incorporated early in the form of unit tests by the developers. A test plan document should be written as it will outline the scope and strategy of the testing as well as the objectives and resources required. Test cases should be written to cover the functionality of the software being tested, including positive, negative, and edge cases. Test execution should be performed by experienced testers and the results documented and managed properly. Defects once found should be managed throughout their life cycle until they are closed. Regression tests should be identified and performed with each new build to ensure that any new defects are found and fixed. Hi everyone, this is Vivek Shrivastava. Welcome to my channel. Today I have for you a lessons learned video that is critical to your startup success. I will speak to you about best practices for software testing, which includes creating a solid test plan, writing effective test cases, and executing the test cases properly to ensure that you release high-quality software even if your resources are limited. If you've been following my sequence of videos, you will have created requirements documents as well as technical documents by now, and even started with some coding as well. Planning for the testing of the software being developed should be considered at this point. For those of you who do not come from a tech development background, testing may not seem significant to you, especially if you come from an assembly line production type of a background. Software testing is significantly different from the testing performed during quality control of the production of non-software products. Generally, in testing for non-software products, a binary result of testing is measured, where either the product passes or fails. A defective unit is generally never reworked to make it functional again. A defective unit is generally discarded and the company takes a loss for that failure. However, in software, a defect is simply an incorrect line of code that can be corrected and the code brought back to a working or passing state. Therefore, software testing is performed in order to assist the developers to find and fix the faulty lines of code that are causing the failure. Software testing, therefore, consists of testing and identifying defects that are then communicated to the developers who then check their code and correct the errors in order to fix the defect. Software testing can start early with the developers themselves performing what are called unit tests that identify defects before the application is sent to the testing team. Of course, the majority of the testing will be performed by the test or QA team, but developers and end users can also contribute to testing by performing unit tests and user acceptance tests, respectively. There are other types of software testing such as load testing, integration testing, performance testing, non-functional testing, security testing, and stress testing. You can find out more about all of these types of testings from an abundance of resources on the net. I will not go into detail regarding these types of testing because what I would advocate, as I always do, is to keep things simple in the beginning. As part of the build, test, and iterate methodology, the test part is where you perform the software testing. Perform functional testing the way an end user would use the system on the area that has been developed and identify and rework any major defects that you find. After the defects have been reworked, look at the section again and see how smoothly it works and if it ties into the original problem or pain point that your product is solving. If not, make the relevant changes and repeat the process. In the early stage, you want to eliminate major defects that are showstoppers, and also verify that what you are building will fulfill the end user's requirements. You do not want to focus too much on eliminating all minor defects, nor do you want to perform all manner of load, performance, and stress testing at this time. Let me emphasize that you will perform all of these types of testing a bit later on down the road, but initially you want to focus on making a stable proof of concept product and perform testing that is relevant to that effort. Before you start any testing, the creation of a test plan document is a crucial step that you must take. Think of the test plan as a roadmap that outlines the scope, the testing strategy, objectives, and resources required for testing. This is especially crucial in a startup where time and resources are often limited. I will not go into details of the components of a test plan or assistance in writing it. What I will say is that a test plan should be written in a simplified format if you are unable to write it in a great detail. You will want to have a test plan document that is clear and actionable. A startup is not exempt from writing a test plan simply because it is not a big company yet. Next, you will want to write test cases. These are specific, detailed steps your testers will follow to verify that the software works as expected. Components of a test case include a test case ID, a title, preconditions, steps, expected results, and the actual results. Keep your test cases simple, focused, and easy to follow. Remember, anyone on your team should be able to understand and execute these test cases, especially in fast-paced startup environments. The test cases should cover all aspects of the functionality and be written to cover positive scenarios, negative scenarios, and edge cases. All this can only be understood properly from analysis of the specification documents written previously, which is why I made a previous video entirely on the topic of specification documents. Once the test cases are written and your developers have created and built the section of the app or website that is to be tested, the test cases can be executed. But execution isn't just about getting through the steps. You need to pay attention to detail. Some common mistakes testers make while executing test cases are: 1. To not follow the steps strictly and to take shortcuts, assuming some steps will work. It is important to not assume that things will work and to test for all steps. 2. To not record the results if the test case passes. The results should be recorded even if the test case passes, and of course should be recorded if it fails. 3. To not document the defects. Once a defect is found, the steps to reproduce it, the relevant screenshots, the section of the app it falls under, the severity of the defect should be recorded and submitted to the developers. 4. To not perform regression testing. Testing should be performed around the previous build's fixes in order to ensure that the fix did not cause any new defects. Regression testing is a type of software testing focused on verifying that recent changes like bug fixes or new features haven't introduced new issues or broken existing functionality, which often happens. The goal is to ensure that the overall system still behaves as expected after any modifications. This is crucial because even small changes can have unintended side effects, especially in complex applications. Regression test cases are typically fewer than the complete suite of tests involved in a full test of the software. A subset of the full suite of test cases written can be used for regression testing. Regression tests should be selected and executed after each build, particularly when the tested software will be released to the end users. And now for automated testing. Automated software testing is the process of using specialized tools and scripts to execute tests on software applications without human involvement. Automated testing is a common buzzword these days, and there's a sense of it being a panacea for all software testing. But having been in the thick of it myself, I would like to highlight a few problems with automated testing. Firstly, it requires a high initial investment. Tools have to be purchased or licensed, the automation scripts have to be written, and the environment to run the scripts has to be configured. Furthermore, the scripts have to be modified every time any changes to the software occur. On top of this, the automated tests will only catch bugs that they have been scripted to catch. They will not catch any other defects that may be present. Automated testing is best suited for repetitive tests and is not suitable for exploratory and ad hoc testing. As startups are generally in a build, test, and iterate process, automated testing is generally unsuitable for them. In the beginning, keep things simple and perform manual testing and track and manage the defects properly. You can always add automated testing later when your software is more complete and it becomes clear which areas are repetitive and suitable for automated testing. Automated testing does not have to test all areas of a software. It can and should be set to test only the areas where it makes the most sense to automate. Manual testing should be employed for the areas of the software where it makes sense to perform manual testing. You or your test lead will have to determine what areas are suitable for which type of testing. The ability to determine this comes with software testing experience, so do not attempt this yourself if you have limited to no experience in software testing. Defect tracking and management. It is extremely important to manage defects properly. Because if you don't, they will slip through the cracks and you will release buggy software to the end user. All the effort in testing and catching the defects will be wasted if you do not have a clear defect management system in place. Make sure at the very least that each defect has a defect number and is assigned to a developer with tracking of where it is within the defect lifecycle. Manage each defect till it reaches the final lifecycle stage of being closed. Good defect management will not only make sure each defect is dealt with, it will also speed up your development as the developers and test staff will work more efficiently on defect resolution. So do not neglect this key area of testing. One final point I would like to make is that in my past experiences in software testing, this crucial part of the development process is not considered important, nor given the recognition that it deserves. Often, an unplanned ad hoc style of testing is performed, and developers or random people with no experience in testing are assigned to perform the testing. Corners are often cut, and far less resources are assigned to testing than what is required. This, of course, results in buggy software being released to the end users. Testing is a very important and complex part of development and should be allocated adequate funding and resources and assigned to competent and experienced professionals. Do not cut corners on this crucial area of your startup. So that's all I had for the topic of software testing. In this video, I wanted to emphasize that having a well-written test plan, detailed test cases, and proper test execution can save your startup from costly defect-related problems down the road. Testing isn't just about finding bugs, it's about ensuring you're delivering value to your users. I hope you found the content useful. Please comment below and provide your feedback. See you all next time. Take care and good luck, everyone.